Continuing with example 6, our rational expression is x cubed minus 4x squared plus 2 all over x squared plus 1 times x squared plus 2. We are simply going to set up the partial fraction decomposition. We won't solve for the coefficients, okay? First thing we need to do is compare the degree of the top to the degree of the denominator. The highest power of x in the numerator is 3, so this is degree 3. In the bottom, if we were to FOIL this out, if we multiply the x pieces together, we'd get x squared times x squared. That's going to be x to the 4th. So the bottom is going to be degree 4. So this tells us that this particular rational expression, it can be decomposed by one of the 4 cases. We do not need to begin with long division here. So we need to examine what our denominator looks like. It is factored. Can it be factored further? Well, if you look at this first factor, x squared plus 1, it is a sum of squares. You square x to get x squared and you square 1 to get 1. You cannot factor a sum of squares, so this yellow factor cannot be factored further. It's irreducible. And then x squared plus 2, it cannot be nicely factored. It is also irreducible. And so we are stuck. We cannot break these two guys down any further. So if we look at our denominators, both are quadratic, okay? If you look inside the parentheses, the highest power of x is the second power. They are quadratic, irreducible, meaning they cannot be factored further, and they do not repeat. Okay, so like if I look at the x squared plus 1, if I look at that factor, it's raised to the first power. Okay, I don't have something like x squared plus 1 cubed. Okay, so we're dealing with quadratic, irreducible factors that are not repeated. So this is case 3, I believe. Okay, so to set up the partial fraction decomposition here, what we're going to do is we're going to be adding some fractions, and basically each of the factors in the bottom will be a denominator. Okay, so the first fraction will have x squared plus 1 as its denominator. This yellow factor is not going to produce a second fraction because this factor is not repeated. Okay, the other fraction is going to have the second factor as its denominator, so the x squared plus 2. And again, because this blue factor is not repeated, there's no x squared plus 2 quantity squared, for example, that means that this blue factor will produce only one fraction in the decomposition. Okay, so this is what the denominators are going to look like. There's only going to be 2 fractions that we're setting up. Okay, we need to talk about the numerators. So for both of these fractions, the denominator is quadratic. The highest power of x is the second power. So that means for both numerators, they need to be degree 1, a degree less than the denominator. So for the first numerator here, we're going to write something linear, so ax plus b. Okay, and then for the second numerator, we are also going to need something linear. We need to use different coefficients. So this is going to be cx plus d. And that is how you would set this up. Okay, you would proceed by the methods we've stated already to solve for A, B, C, and D. Okay, we are just setting up in this particular example. Okay, all right, let's move on to part E. Our expression is x to the 4th plus x squared plus 1 all over x squared times x squared plus 4 squared. All right. Let's talk degree here. The degree of the numerator is 4. In the bottom, we have x squared. So this is really x times x. And then you're multiplying this by x squared plus 4 times itself. And so if you take all the x pieces and multiply them together, x times x squared times x squared, that is going to give you, if you add the exponents, this is going to be x to the 6th. So this is degree 6. The numerator's degree is smaller than the degree of the denominator, so we do not need to perform long division to start. Okay, So let's think about what our denominator looks like here. Okay, so in the denominator, x squared, you can actually factor that. It breaks down into x times x, okay? And then inside the parentheses, we have a quadratic factor. X squared plus 4 is the sum of two squares. You square x to get x squared, and you square 2 to get 4. The sum of squares does not factor, so this is a quadratic irreducible factor, okay? So if inside the parentheses, okay, that's your factor, but the whole thing is squared on the outside. So this is what the denominator really looks like. If you were to write it out, you have to multiply x squared by itself twice. X squared plus 4, I'm sorry, x squared plus 4 by itself twice. So this is what the denominator looks like, okay? So if you notice, you have repeated factors here, okay? We see x squared plus 4, okay? This x squared plus 4 is quadratic. It's irreducible. We can't factor it any further. And it's repeated because we see it in the factorization twice. On the other hand, the other factor is x, okay? X is linear. It's x to the first power. It's irreducible. I can't break this guy down any further, okay? And it's repeated because I see it twice in the factorization. I see the x times x, okay? So we're dealing with one each. We have a linear factor and a quadratic factor. We can't break either down further, and they're both repeated, okay? Let's begin with the x squared, the x factor, okay? So to set this up, okay, we're going to start with one denominator. The first denominator is going to be x, okay? But then this is a repeated factor, so you're going to have to bump up the power, okay? If we bump up the power, then that's going to give us the highest power of x, this x squared, the highest power that this particular factor is raised to, okay? So that's what the blue factor will turn into as far as the partial fraction decomposition. And then we're going to have to create the fractions that come from the yellow factor, from the x squared plus 4, okay? So it's going to produce two fractions because its power, it's repeated twice, okay? Just like the blue x was repeated twice, it produced two fractions. The yellow factor is repeated twice, it's going to produce two fractions. The first fraction will have x squared plus 4 raised to the first power as its denominator, and the second one will have x squared plus 4 raised to the second power, okay, as its denominator. Okay, so the denominators are good, okay? We need to go to each one of these and talk numerators, okay? For the first two fractions, the factor is linear. We have x and x times x, okay? So it all depends on the factor itself. The factor is linear, so the numerator will go down a degree and be degree 0. Okay, so you're going to have an a and a b on these first two fractions. When you look at the remaining two fractions, again, it's all about the factor, okay? Here the factor is raised to the first power, and then here the factor is raised to the second power. The factor itself is x squared plus 4. That is quadratic. And so that means the numerator will go down by a degree, okay? From a factor of degree 2 to a numerator of degree 1. And you're going to have to use coefficients that haven't been used yet. So this is going to be c times x plus d, that's linear. And then again, even though we have something squared, you're still going based off of the fact that this is a quadratic factor in the bottom. And so in the numerator, you need to have something linear. Okay, so this is how you would set this one up. Okay, I can go ahead and remove this because I don't need this. It's okay to have it, but I don't need it. So this is how you would set this particular one up. Okay, and then you'd have to go through the motions of solving for a, b, c, d, e, and f. Okay, let's try one more that we just set up. Okay, this one in part f is x cubed plus x plus 1 over x times 2x minus 5 cubed. times x squared plus 2x plus 5 all squared. Okay, very complicated. Okay, let's examine the degrees of the top and bottom. The numerator is degree 3. If we write out the denominator, this is x times 2x minus 5, but the 2x minus 5 is multiplied by itself 3 times. And then we've got this x squared plus 2x plus 5 multiplied by itself twice. And so if we're just multiplying the x pieces together, this is going to be x times 2x times 2x times 2x times x squared. So this is going to be x times 2x times 2x times x, times 2x times x squared. So this is going to give us 8 times x, to just add the exponents, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is degree 8 in the bottom. Okay, so we do not need to do long division to start. Okay, so that's great. When you look at your denominator, okay, we need to make sure that everything is factored completely. It is factored, but is it factored all the way? Well, this first factor of x is not going to break down any further. Okay, then you have 2x minus 5. That's your factor. It is repeated 3 times in the factorization. The 2x minus 5 is linear. It does not break down any further. Okay, then you have a quadratic factor, the x squared plus 2x plus 5. You may want to try to see if that factors. So if we have x squared plus 2x plus 5, if you just play around with it, the x squared will break down into x times x, and then you need the numbers to multiply to be positive 5. So there's really no way to arrange this, because these numbers would either have to both be positive or both be negative. There's no way to get a plus 2 in the middle. So this quadratic factor is irreducible. You can't break it down any further. Okay, so knowing this, we can start writing our partial fraction decomposition. Okay, we have one linear factor, and I'll write this out. Okay, so the yellow factor is linear. It's irreducible. We can't break it down anymore. And it's not repeated. And then the 2x minus 5, it is linear. It's irreducible. You can't factor it anymore. It is repeated, because in the factorization, like I said, if you wrote this thing out, it's going to be x times 2x minus 5 times 2x minus 5 times 2x minus 5. It will be repeated 3 times. And then as far as the quadratic factor goes, the x squared plus 2x plus 5, it is quadratic. It is irreducible. You can't factor it any further. And it is repeated, because in the factorization, if I wrote it out, okay, this denominator would have the factors x squared plus 2x plus 5 times itself, because it's squared. Okay, so knowing these conditions, or the criteria that the characteristics of the denominator here, we can form our partial fraction decomposition. Okay, let's first deal with the yellow factor, the x. Okay, so what we're going to do here, it's linear, irreducible, not repeated. Because it's not repeated, it's just going to produce one fraction with the factor as its denominator. Okay, it is degree 1. So that means the numerator has to be a degree less. So it's going to be degree 0, which is just a number. Okay, so that's where this one goes. Okay, if we move on to the blue factor, the 2x minus 5, okay, it is linear. We can't factor it any further, but it is repeated 3 times because it's cubed. Okay, so it's going to produce 3 fractions. Okay, so the first denominator is going to be the factor 2x minus 5 raised to the first power. Then you're going to raise it to the second power. And then you're going to raise it to the third power. Okay, you stop here because you've reached what you see in the original problem, the 2x minus 5 cubed. okay? As far as the numerators are concerned, remember, in each of these, the factor is 2x minus 5, which is linear, okay? Don't get confused by the square and the cube. That just means it's repeated. It is a linear factor at the end of the day. So what goes in the top has to be 1 degree less. The blue factor is degree 1, so that means the numerator needs to be degree 0 or just a number. And we have to use different coefficients every single time. Okay, so we've taken care of the yellow factor, we've taken care of the blue factor, we need to take care of the green factor. Okay, the green factor is x squared plus 2x plus 5. It is quadratic. You cannot factor this thing any further, but it is repeated. It is repeated twice, since in the original problem, this x squared plus 2x plus 5 is squared. Okay, it will produce two fractions because it's repeated twice. The first denominator is going to be the factor itself, raised to the first power. And then in the second fraction, you will see it raised to the second power. We stop because this piece matches what's in the original problem. Okay, so that's how you handle the green factor. Okay, we need to figure out what goes in the top. Okay, for both of these fractions, the factor is x squared plus 2x plus 5. Okay, again, you don't want to worry about is it raised to the first power or is it raised to the second power. What matters is the factor is x squared plus 2x plus 5, and that is quadratic. So that's the second degree. You need to go down a degree to degree 1 for the numerator, so you need to write something linear in the numerators. Okay, you want to use coefficients that have not been used before. Okay, so this is going to be e times x plus f, and then this next numerator is going to be g times x plus h. Okay, so this one is a beast. I would never make you solve something like this, because if you had to solve it all the way out, you'd have to solve for a, b, c, d, e, f, g, and h, and that is just insane. Okay, but I at least want you to see how you would set something complicated up. Okay, this is a good exercise to make sure you're recognizing the case, each case, and how to handle them.